good to teach people in your organization root cause analysis skills, but people who are not going to then use them in practice, if you teach them, it's just a waste of time, isn't it? Hello, I'm Tom. Welcome to my channel. We'll talk about continuous improvement in an industrial setting. And today's video, it is not so much about the root cause analysis or problem-solving skills themselves, although we'll go over them quickly. It is about when do you teach them and sort of to whom, right? Who is the correct audience to learn these basic skills in problem-solving? Now, when we go over root cause analysis or problem solving, I like a couple of the basic tools just because they solve 90-95% of your problems for you normally. When we're really talking about getting into advanced problem solving, there are different tools that will also help you. But these three, they are going to be your workhorse. They are really going to help you with almost all of the things you need at the, well, I was going to say basic level, and that is true, but even when you are quite far with solving problems and getting to root cause in your organization, then still these tools will be more than enough for 90-95% of the issues you encounter. So what are they? They are the 5 W's, 2 H's, or 5W, 1 H. It's a bit how you like it, preferably combined with is not. Problem definition. And so we really describe what happened, where it happened, with whom. So that's sort of which shifts, or maybe it's specific people or things like that, or people who are trainees, they do have it, but the experience do not, or stuff like that, right? So where does it happen? When does it happen also? And it could be day or night, but it could also be things like every time, within an hour after a product change, we have these type of problems. Key information. And how does it happen? How much is generally affected, and specifically how much was affected at this issue that we're describing. So we're really defining what is the problem by describing what happened. But by the way, if you want to get a bit more on these, I've got nice videos on them. I've also got a template that takes you through the 6 steps of root cause problem solving. It's absolutely for free. Go follow the link up and down. I'll put them in, but get the template that takes you through the 6 steps. And if you're interested, I got a full course on explaining how to do these and how you can get a team through it. Because really, these things, and we'll get to it in a bit, you want to do together with other people. And I think in your role, assuming you're like a quality engineer, CI specialist, that type of role, and even if you go through those roles within your career, line managers, slightly higher managers, you are being called upon to assist in finding root causes, but also to do improvement teams, things like that. These are key skills, but you don't just want to be able to do it yourself. You want to be able to do it with other people, to lead people through this brainstorming and the structuring of their thoughts and the way that their logic works. That is what my course is all about. So this is problem definition. Then you go broad, right? You brainstorm. So basically, we have a couple of things here, and it leads to a problem statement, right? That then becomes the head of our fish, the fishbone, or the 4 M's. Well, in Ishikawa, it's all the same. So your fishbone analysis, you have a very good problem definition that goes into the head, and we're then going to explore the direct causes, so what really caused it. Right? And the reason why we use this fishbone is because it may not always be so clear as to what caused our problem. And we would like to trigger people to think, what possible machine causes are there, right? Which factors on the machine plane are there, or man, or method, or material, the 4 M's. We could include also the milieu or environment and the measurement, but the idea is to create more sort of thoughts, structure that, and trigger people to think about factors and causes that are not directly apparent. So this is broadening your scope. Then what we will do is, we got a bunch of them. And then some of them, or actually most of them, we go check and we say, nah, checked it, good idea, but just not this time, right? These were not it. And a couple of them are actually true. Now that they're actually true does not automatically mean that they are the main cause. In the course, I also explained that you can go with your gut on this. So that is the team's gut, preferably. You pick one, maybe two. And of those, you say, okay, let's dive deep on it. So we go through the 5 whys to get to a root cause. So the whole idea of the 5 whys is that you take a direct physical cause, but I mean, if this is a method cause, it might be because we simply don't have a procedure to say how high the temperature should be, right? Something like that. There's nothing wrong with the machine. If you set it to 150, it stays at 150, but we don't even know if it should be 150 or 180, right? We just do some method type of problem. So why don't we have it? So that's because we got a new product, we test new products. The thing is, in the top levels of your 5 why, you stay into sort of the direct type of causes, right? So we have the immediate cause, but these top level causes, they are also the things that you need to fix. This is super important, especially if we're talking like technicians, maintenance engineers, people like that, but also quality and safety. So we can fix that the gear broke, right? The gear wheels broke. Fix it, please correct that. But why did the gear wheels broke? Well, they broke because, there's too much tension, misalignment of an axle. We're somewhere here, right? We have got to get that axle aligned again. That is fixing sort of a root cause. Now, if you can get this into your organization's thinking, that at least they're aligning axles instead of only fixing the gear wheels and then next week fix it again, you have already won a lot. But the 5 why, so this is sort of the 2 to 3, 2 why type of level. The 5 why level, it goes deeper, and it is on, so how do we get that axle out of alignment? Don't we have a check for it? And then at some point you get to organizational types of root causes. Things like we don't have an inspection plan on axles and on the alignment of our machine. So let's get that fixed. Those are the root causes that'll prevent the axle from getting into misalignment again. If you can get your organization to go to those organizational problems that are really at the root of what allowed these more physical causes to happen, then you have preventive countermeasures, so really into the future. And the thing is a bit, if you are in ISO thinking, the problem itself, you correct it. Well, this is a correction. You could say, getting that gear wheel, so we're getting that product, and then the product and the gear wheel that sort of caused it, that is the correction. Then the corrective action prevents that exactly that same problem from happening again. So we're going to align the axle so that the gear wheel doesn't break again, so that we don't get the defective products anymore. Right? That is a corrective action. Now, the preventive action is to prevent similar things from happening sort of all over your organization, into the sister machines as well, into slightly different things. So we're going to dive deep into the root causes. We're going to get to sort of an organizational problem, most often a method, things that we don't have procedures for it in place, we don't have checklists, things like that. We don't have the knowledge to do this. You fix that, guarantee this will sprout out to other parts of your machinery, your organization, because it will say, wait a minute, if we don't have an alignment check on machine A, machine B and C, we also didn't have alignment checks. Get it done, get it into the system, improve how we maintain our machinery, how we maintain our standards. That is the whole idea. Now, these tools, But these are at the core of root cause analysis, root cause problem solving. This is the real root cause analysis part of the root cause problem solving. I suggest that you teach them, and you teach them pretty broadly throughout your organization. But not everything to everyone. See, this is about really describing what happened. This is, and that's basically always useful. This is, if you don't really see a cause, help brainstorm with a team of experts. And this is finding the underlying principles, the underlying causes. These are really about understanding the physics and the cause and effect relationships behind your problem. This is to improve your organization. This is, if you don't really know what the cause is, this is just describing in very clear words what the problem is. Now, when you have a team of, Kaizen team, improvement team, root cause, problem solving team, whatever, right? The people that we put into Kaizen events, that we put into improvement projects, so that really the team members that we're going to put together for a couple of weeks, even maybe, 3 months, they should really know these tools. Almost irrespective of the type of problem they are solving or the type of improvement they are doing. Because if you're doing an improvement, you almost certainly also want to do these type of things. And definitely you want to do them as part of the project because you're going to run into problems at some point. So please, they need to be learning all of these tools. Now, when we're talking about the star people in your organization, and these are people that are, they're like the helpers for your operations. And I'm thinking of production specialist, quality engineer, reliability, basically anyone with the title engineer, safety engineer, quality engineer, product engineer, process engineer, reliability engineer, maintenance engineer, anyone with engineer. If they're not already in this group, because they get selected onto those teams a lot, but roll that out. But this is also most maintenance technicians as well, because these are people you want to be problem solving. They're sort of problem solving on a daily basis. It's sort of their work, or they get called into it. What they should know is definitely how to describe a problem very well to themselves and others. And they need to be able to do that root cause analysis to find at least the underlying, more physical causes, but also to find those organizational improvements. Right? So your technicians, it would be great if they come up with improvements to the whole maintenance system. But if you're talking about the engineer type of layer, those are exactly the people that are meant to improve our company's systems. So they need to know this. The fishbone, well, can do, but not really needed, right? Not until you ask them to join a team. This is daily work for them. And you can also just go from the problem. If you have a good problem definition, you might very well also immediately see what the cause is. The direct cause that messed things up today, put it here, do the root cause analysis. You don't have to go through this. So, I'm allowing you to just skip this whole step. If you know what the cause is, just put it into a 5 why. Don't use the fishbone at all for 80% or so of your problems. And then we get to just your basic technicians. They might be already in here, bit sort of, and any operator. Now, everyone in your organization might benefit from it, but when you have the type of organization where you sort of have an operator of a line who is really responsible for that line's working with a couple of helpers, so to say, right? Or you have some temps doing packaging work. I'm now talking about that operator, maybe that senior operator. Look a bit into how do you organize your work, but those people who really pilot the process, who operate the process. I'm talking about them. And your basic sort of maintenance staff, right? And these might even be elevated already to the higher up level, because you want them to be able to so that get the root cause. But any operator, please get them to describe their problems thoroughly. Teach them this system. And if you use 5 Ws, 1 H, and you don't really care about the is not there, fine, right? Go with the problem definition tool that your company wants to teach, and especially if you're going to teach it to almost everyone. Maybe skip this detail, just go for describe it in a good way. Absolutely fine. But everybody needs to be able to really describe the problems they encounter. It'll make life so much easier for the mechanics that they call in when there is a problem, for logging it in your maintenance systems, for logging it in your quality systems. Because the same goes for defects and quality issues, right? You want your first line people. So in here, we can also have your quality control staff that don't really need to solve the problem, but they need to identify it. They need to know that. And probably, don't bother them too much with these tools, because you don't really want them, so you don't yet expect them to be solving the problem. So don't bother them too much with the root cause analysis part, but teach them how to describe what's happening in a good, structured way. Now, this will take care of you teaching the tools to those who need it, but also ensuring that the training you give is not going to be purely theoretical. The training that you give, if you sort of follow that matrix, is stuff that these people are going to then use. Of course, that also means that in your control meetings, in your walkarounds, whatever, you start asking for good problem definitions, right? So after you do this training, start asking for it, start demanding that people describe, in more detail what happened, when it happened, how much was affected, where specifically did it happen, so things like that. Really start demanding that. And of your specialists, indeed also start demanding that they show you that they did a 5Y and that they have both the top level and the underlying organization stuff. So get it also clear to them that you didn't just train them, you now want them to use it. Do not please get this stuff on paper after you did it, right? I see that so often. Let's, after we solved everything, make a formal fishbone out of it just to show the management what we did and how good we are, really nicely doing our continuous improvement stuff. And we set up a couple of 5Ys. It's looking really nicely. And use it to actually solve the problem, right? If you didn't use it at all, you might actually want to use the 5Y anyway, because most of the time what I see is that if you don't really use the 5Y, if you sort of do it after the fact, but then with somebody who can coach you on what the 5Y should have been like, you'll see that people went to this second, third level, and they called that the root cause. The misalignment of the axle, that's the root cause. And then when you push a bit further, they will come to, oh wait, we don't have inspections on this, right? We don't have a check. So maybe that one you can do after the fact, but it'll give you so much more if you do it really on the floor. So these are the people you teach. Not every tool to everyone. Keep the tools as simple as possible also to use. Don't put it into a completely locked down Excel like I did for such a team. On the floor, allow people to just do it on a piece of paper or a whiteboard, right? So keep it low input, low difficulty. When you really want to structure it, because you know that you weren't able to solve this problem with simple tools, then you want to go through all the steps a bit more structuredly. So go check out my template where we get all of this. Go check out my course if you want more info on how to do this. But if you are looking at, who am I going to teach all of these things? I hope that this triggered you and helps you to put the training plan for the upcoming year or whatever into your improvement calendar. If it did, don't forget to hit that like button. For now, I wish you the best of luck solving problems. And as always, don't forget to also enjoy the continuous improvement journey.